Hello everyone, this is a video for Algebra 1A Live and Algebra 1A Self-Paced for week 1, a review of real numbers. So we're going to be talking a lot about real numbers, words like natural numbers, whole numbers, integers, rational numbers, irrational numbers, lots of good stuff. For this week 1, after you watch this video, make sure you read the sections in our online CK12 textbook. Take notes while you're reading and watching this video, do some practice problems. Make sure you're starting to understand some things, and when you're ready, go in and do the weekly assignments to show what you've learned for this week. All the assignments will be in Canvas for you to do. If you have any questions, come to my online classroom or message me, and we'll get clarification and help for you. All right, for week 1 in this video, we're going to be defining what rational numbers are, ordering them on a number line. We're going to do a lot of review with fractions, getting comfortable with fractions, writing them in simpler form, reviewing how to add and subtract fractions and rational numbers, multiplying and dividing. We're going to do some problem solving, getting into a little bit of algebra with some variables there, and then we're going to touch a little bit on square roots and irrational numbers. Okay, so let's start this off. What are rational numbers? Well, we've got different types of numbers as we work with math. Obviously, we have natural numbers. In kindergarten and on, you learn how to count 1 candy, 2 candies, 3 candies. You learn how to count objects, right? 1, 2, 3, 4, and it goes on and on. You can count as many as you want. So in math, as we get more advanced, that's how we would list out all the natural numbers, things that we can count, 1, 2, 3, and they go onward. Well, eventually you start to grasp this concept of 0. And when we add 0 to all the natural numbers, now we have all the whole numbers. So 0, 1, 2, 3, on and on. That is all the whole numbers right there. Around 6th, 5th, 6th, 7th grade, you start to learn about negative numbers, right? So negative numbers include all the whole numbers, but the opposite. So if there's positive 3, we also have negative 3, we have negative 2, we have negative 1, and then we go from 0, 1, and 2, and 3. And on the number line, I can go as negative as I want, and I can go as positive as I want. So both directions. Now finally, we're going to combine all of those. A rational number is simply any number that can be written as a fraction. All right. So what that means is 3/4 would be a rational number. The number 8 would be a rational number because I can write it as 8 over 1. Negative 1/10 would be a rational number. 0.45 would be a rational number because that's 45 hundredths, and I can rewrite it as a fraction, 45 over 100. So we're going to be doing a lot with rational numbers. Okay. Again, reviewing all this stuff, adding, subtracting, multiplying, dividing, algebra uses all those skills, right? We use all sorts of numbers. We use all sorts of positive numbers, negative numbers, fractions, decimals, stuff that we've been really hitting and learning in middle school. We really want to get that all fresh, really get that solid, so that when we dive into more complex algebra skills, we're good to go. So here we go. Let's start off. Let's plot each of these numbers. These are all rational numbers on the number line. Figure out where it goes, and we'll use its decimal. So converting fractions into decimals is as simple as using your calculator. This is 2/3, but I also can think of it as 2 divided by 3. So if I pull out my calculator and I do 2 divided by 3, that's approximately, I'm going to use the little approximately symbol, 0.667, or I could say it's exactly 0.66 repeating. Well, on the number line, that's greater than 0 and less than 1, so that's going to be right about here. All right, 7/4. Let me do 7 divided by 4, and that's equal to 1.75, and that's exact. That's greater than 1, less than 2, so 1.75 is going to go right about there. All right, 24 divided by 32 is 0.75, but this is a negative number, so it's negative 0.75. So I got to go in the negative direction, right about there. And finally, 14 fifths. 14 divided by 5 is 2.8. And so we can plot that on the number line right about there. So again, we want to be able to be comfortable knowing which number is greater. 14 fifths is the largest number, or the greatest number, because it's to the far right on the number line, whereas negative 0.05 would be the smallest number. It's to the far left on the number line. So number lines helps us see which numbers are greater, which numbers are smaller. We're going to be doing a lot of plotting points on number lines, coordinate planes, working with numbers, just making sure we're comfortable in that skill. All right, simplifying fractions. Okay, how do we compare? Which number is bigger, 2/3 or 24/32? How do we compare them? Well, fractions, we want to be able to make them adjust the size, so simplifying helps compare them. So let's go. Simplifying means I want to find, are there any common denominators in the top or the bottom that I can divide out. 2/3 is already simplified because there's no number that divides evenly into 2 or into 3. However, 24/32 does. I can divide both of them by 8. 8 goes into 24 and 8 goes into 32 evenly. And so if I simplify this fraction down, 24 divided by 8 equals 3. 32 divided by 8 equals 4. So 3/4, negative 3/4 is the same fraction as negative 24/30, not 30 halves. But it's helpful to be able to rewrite them. So now I can say, well, how does 2/3 compare to negative 3/4? It's a little bit easier to work with fractions when we can simplify them that way. It's also helpful to rewrite improper fractions as mixed numbers. When I say improper, what I mean is the numerator here is larger than the denominator. So this would be called an improper fraction, 14/5. Well, let's change it into a mixed number, and a mixed number is a mixture of whole numbers and fractions. So to do that, we got to do some division. This is 14 divided by 5. I can think of this as a division problem. So how many times does 5 go into 14? Well, 5 goes into 1 time. 10 would be 2 times. 15 would be 3 times, but I can't fit it in 3 times because 15 is greater than 14. So 5 goes in 2 times, which would be 10. And 14, if I take away the 10 from the 2 5s that I put into it, leaves a remainder of 4. So as a mixed number then, it would be 2, because 5 goes into 14 2 whole times, but there's 4 left over out of 5 that I was dividing by. And so it turns into 2 4/5. This would be an example of a mixed number. And to double check it, use your calculator. Do 14 divided by 5 and see if it's the same as 2 and 4 divided by 5. And you should get 2.8 for both of them. All right, so in summary, we can find the decimal. Turning fractions into decimals helps us quickly plot numbers on a number line, helps us compare fractions. We can find similar fractions by either multiplying or dividing the numerator and denominators. And then we want to be able to work with rational numbers, moving back and forth from mixed number form to improper fraction form. Again, these are all skills that we're going to need to draw on and be really comfortable with in our algebra class this year. Okay, let's review some adding and subtracting. From mixed number to improper form, here's the steps that we need to do. If we want to add or subtract fractions, we want to get them all to improper form. Make sure we have common denominators, so we're adding the same thing. And then we can add or subtract the numerators. And finally, simplify the results. Let's take a look at an example here. All right, let's start working on this one here. So we've got 3 1/5 plus negative 4/3. Again, following our steps. first thing I need to do is put them into improper fractions. So 5 times 3 is 15. It's 15 thirds, the same as 3. Plus the 1/5 gives me 16 fifths. 4 thirds, negative 4 thirds is already in improper fraction form, so we're good to go. So now we've got the problem as 16 fifths plus negative 4 thirds. Now the problem is, however, I've got different denominators. I want to have common denominators. Fifths is a different size fraction than thirds. So now we've got to change these to similar fractions, but with the same denominator. So 5 and 3, what I'm going to want to do is turn them both into 15ths. Because 5 goes into 15 and 3 goes into 15. So 16 fifths, 5 to get to 15 was multiplied by 3, so I got to multiply 16 by 3. Multiply the numerators and denominators by the same thing. 16 times 3 is going to be 48. So 48 over 15 is the same as 16 over 5. All right, do the same thing with negative 4 thirds. 3 times 5 gives me 15, so 4 times 5 gives me negative 20. Now I've got common denominators. Now I can take a look at what's in the numerator and add these things together. So we've got 48 fifteenths plus negative 20, so 48 plus negative 20 is going to give me positive 28 fifteenths. Ooh, that green is a gnarly color. I don't like that very much. Okay, you think we're done, right? We've added them together. We're successful. However, I've not simplified my final answer. Let's change it into a mixed number. 15 goes into 28 one time. And there's a remainder of 13. And if I look at 13 28ths, are there any common numbers that divide 13 and 28? No, they're not. So there is my final answer. Okay. So in summary, when you want to add or subtract rational numbers, you want to get improper form. Helps us not get confused with subtraction or negative numbers. Make sure you get common denominators because we want to have the same size fraction. Don't forget to simplify your final result. Put it back into a mixed number, simplify the fraction. You can quickly check your work by using a calculator and decimals just to make sure that you added them correctly. Okay, let's do an example of multiplying. So if I want to multiply fractions, again, we change it from mixed form to improper form if we need to. Multiplying is nice because we just multiply the numerators and multiply the denominators together. It's okay we don't have common denominators. And finally, we can simplify the resulting product. So let's do an example here. We're going to multiply the same number. Let's multiply 3 1/5 times negative 4 thirds. So we've already know that putting them in improper form is going to be 16 fifths times negative 4 thirds. And at this point now, we change to blue. At this point now, I just multiply the numerators. So let's multiply 16 times negative 4 to get negative 40 is negative 64. And now let's multiply the denominators. 5 times 3 is 15. All right, we've successfully multiplied our fractions. Now we've got to do some simplification. So 15 goes into 64 4 times. 15 times 4 is 60. So negative 4, but there's a remainder. If I take away the 60, there's a remainder of 4 left over. So 4 fifteenths. So there we go. We simplified it as a mixed number and then 4 over 15. I can't simplify that fraction anymore. There are no common numbers that go into 4 or 15. So there's my final answer. 3 1/5 times negative 4 thirds is negative 4 4 fifteenths. Dividing fractions is really similar to multiplying, but I have to change it from a division problem into a multiplication problem, the reciprocal of the second fraction. So division and multiplication are really, really similar. So let's divide the same numbers we got, 3 1/5. Let me get out. Let's rewrite it in improper fraction. So that's 16/5 divided by -4/3. Now, since multiplication is easier, let's change it into a multiplication problem. So this becomes 16/5 multiplied by -3/4. These are the same problem. One is just written as a division problem. The other one is written as a multiplication problem. But now we can multiply the numerators and denominators. Let's see what we got here. So 16 times 3 is going to be -48. Multiply the numerators there. 5 times 4 is going to be 20. 20 goes into 48 two times to get 40 with a remainder of 8. So that's now -2 and 8/20. And 8/20 I can reduce down into, let's see, 4 goes in the numerator and the denominator, so it turns into -2 and 2/5. So there's my final answer. If I do it as a division problem, -3 1/5, -4/3 goes into it, -2 and 2/5 times. So in summary, when we multiply and divide fractions, you want to have improper fractions again at the beginning. When we multiply, we don't need common denominators. We just multiply the numerators and denominators. If it's a division problem, we turn it into a multiplication because they're related. We can take it, dividing by a fraction is the same as multiplying by the reciprocal of the fraction. And again, you can check your work by using a calculator, by approximating, make sure your answer makes sense in the context of the problem. All right, let's do an application problem, right? Let's apply this to thinking problem solving. So Andrew is driving down the freeway. He passes mile marker 27 at exactly noon. At 12:35, he passes mile marker 69. What speed in miles per hour is Andrew traveling? All right, so we got to kind of make sense of some things here. First, how many miles does he travel? So he started at mile marker 27 and then ended up at mile marker 69. So 69 minus 27 would be how many miles he traveled in that period. Well, 69 minus 27 is 42. So he's traveled 42 miles. All right, so now how many hours has he traveled? Well, he started at noon, which is 12 o'clock, and then 12:35 is 35 minutes later. So 35 minutes, but we want to know hours, right? So 35 minutes is 35 out of 60 hours. So I've got a fraction. So now what was his speed in miles per hour? Let's see. Well, his speed now is 42 miles per 35, 60 hours. And I need to do this division problem. What is 42 divided by 35 over 60? Let's rewrite this a little bit differently. We can change it as 42 over 1 divided by 35 over 60. Whoops. 35 over 60. And then change it in a multiplication problem, that turns into 42 over 1 times 60 over 35. So there we go. We're going through all of our steps, right? And let's do some multiplication now. So 42 times 60 is going to be 2,520. And 1 times 35 is 35. That's pretty easy. I want to simplify this thing down. I get improper fraction. Let's see how many times 35 goes into there. So divided by 35. 35 goes into 2,520 exactly 72 times. I just pulled out my calculator and did this division problem. it equals 72, and there's no remainder. So what I see then is he goes 72 miles per 1 hour. He's going really fast. Probably needs to slow down a little bit before he gets a ticket. But there we go. We just did a problem thinking through using fractions, doing a division by fraction problem, getting to an answer that makes sense. And it does make sense, right? If he goes 42 miles in pretty close to half an hour, then he's probably going almost twice as that in 1 hour. And that makes sense with 72 miles per hour. All right, last thing I want to touch on this week, square roots. So square root is the opposite of squaring. Just like when we add or subtract, adding and subtracting are opposites, multiplying and dividing are opposite things. I can square a number and I can take the square root of a number. That gets me back to what I started with. So let's take a look at this example here. We've got the square root of 121, right? What does that mean? Well, I'm looking for a number that when I square it, some number times itself is going to turn into 121. Well, we can think about this, but the number we want is 11. Because 11 times 11 equals 121. Or I can rewrite that as 11 squared equals 121. And so square rooting works that way too. 121, the square root, is the opposite. The square root of 121 gets me back to 11. So there we go. The square root of 121 is 11. And you want to have memorized all the following square roots. Here's squares. 2 squared is 4. 3 squared is 9. 4 squared is 16. On and on and on. You want to remember the opposites. The square root of 100 gets you back to 10. The square root of 81 gets you back to 9. So take a look over these, study these a little bit. You might write them all down and have them out this week as you're practicing the problems. Some of you might already know, some of you might already have all these memorized, but you want to be really familiar and comfortable with these numbers. Because again, we do a lot of square rooting and squaring throughout this whole course, especially when we get into quadratic equations and polynomials. All right, so what happens if I have the square root of 120? So square root of 121 was an exact number. It was really nice. I have the square root of 120. This gets a little bit weird. So we're going to use our Desmos calculator to explore this. So I'm going to pull out real quick here. I'm going to open up this. And let's access our Desmos calculator. We can do square roots on here. Again, you don't have to buy a calculator for this course. If you go to desmos.com/calculator, I got the link in our class. We can do square roots in here as well. Open up the keyboard. You'll see on the bottom there is a square root sign. In the square root of 121, that was the last example we did, so we can see that's exactly 11. But if I want to do the square root of 120, I do not get an exact answer, right? I get 10.9544511,501. But in reality, this is just rounding it. The Desmos calculator can only show me so many digits. 120, the square root of 120, is an irrational number. It is a decimal that goes on and on and on, does not end, and I can't write it as a fraction, so it's irrational. But there you go. We can use the Desmos calculator to approximate. The square root of 120 is about 10.95, and then we round it, right? Let's go back to our PowerPoint now. So approximate using our Desmos calculator. It was approximately 10.954. And depending on the problem, you might round it more, you might round it less. But there's again our symbols for approximately. All right, so in summary, the square root is the opposite of squaring a number. Go back and forth just like adding or subtracting. When we take the square root, we call that little symbol a radical sign. You should know the first 10 digits squared, all the way from 1 to 10 and the square root. And then you should be comfortable using your Desmos calculator to approximate square roots that are not perfect square roots. All right, so again, what did we do? We talked a lot about rational numbers. We did a lot of examples in terms of putting them on a number line, rewriting fractions in simpler form, reviewing, adding, subtracting, multiplying, dividing fractions. We did a word problem where we had to divide fractions, and we touched a little bit on square roots. Again, if you have any questions for this week, give me a call, contact me. I look forward to working with you and looking over your work for the week, and have a good week.